This is notes for systems of linear and quadratic equations. We're trying to find the solution where the line in the quadratic equation cross. So we're looking, it says on the graph below, draw the quadratic parent function, which is y equals x squared. We will then draw a line to see the different number of solutions possible. So x squared, I'm going to start at the origin. 0 squared is 0. 1 squared is 1. 2 squared is 2 times 2, that's 4. 3 squared, that's 3 times 3, it's 9. Oops. And the good thing about this, the exponent is even. So we talked about even and odd. Even, it's symmetric about the y-axis. Meaning I could take this arm and flip it across the y-axis and I'd have my quadratic. So 1 squared is 1, well, negative 1 squared is 1. 2 squared is 4, negative 2 squared is 4. Positive 3 squared is 9, negative 3 squared is 9. Then I'm going to just draw some random lines. If I had a line that crossed here. That's one line. What if I had a line that crossed well, that one doesn't cross at all. So that's my 0. What if I had a line that crossed around here? I'm going to say it's close enough that it only crossed once. So I could have 0, 1, or 2 solutions. There's no possible way for me to have more than 2 unless I had a line that bent back on itself, and that's not a line anymore. So now let's look at what it would look like if we were solving algebraically. So I have 2 equations, and they both have y equal. So I could do some weird stuff, but I already have y solved for. So I'm going to take this piece and replace it here. So I already have y, so I know what y is. It's 2x plus 1. So 2x plus 1 equals x squared minus 5x plus 7. So I need to get all my terms on one side. I need to collect my like terms. So I do have an x term and an x term, so I'm going to move this one over. It's positive, so I have to subtract it for that to add to 0. And then plus 1, I'm going to subtract 1. So now I have 0 equals x squared I had negative 5 and I subtracted 2 more, so that's negative 7x. I had 7 and I took away 1, so it's positive 6. So I could see if this factors, or I could just use the quadratic formula. A would be 1, B would be negative 7, and C is 6. I'm going to factor. I need two numbers that multiply to 6, but somehow add to be negative 7. X times x gives me x squared. I could use 2 and 3. 2 times 3 gives me 6, but they add to give me 5. Even the negatives of the two numbers, because they have to be the same sign. If they multiply to be a positive, they both have to be either positive or they both have to be negative to give me a positive product. So 2 plus 3 is 5, negative 2 plus negative 3 would be negative 5. So those are out. The only other combination I could possibly use is 1 and 6. So 1 plus 6 gives me 7. I need negative 7, so it has to be negative 1 and negative 6. So I'm multiplying two things that equal 0. So either one of them is 0, or they're both 0. Or I have no solution. That's my 0, 1, or 2 solutions. So if x minus 1 equals 0, that means x had to be positive 1. Add 1, so x is positive 1. Then x minus 6 equals 0. So x is 6. So just having x doesn't mean anything. I need to find out what y is. So the easiest one to use is a linear equation. I'm not squaring anything. All I'm taking is my x, multiplying it by 2, and adding 1. So 6 times 2 is 12, plus 1 is 13. And the 1, 2 times 1 is 2, plus 1 is 3. So now I'm going to check. If I put in 6 here, I'm going to need a calculator. Six squared is 36 minus 5 times 6, that's 30. So 36 minus 30 will be 6, plus 7 is 13. So this one checks out. 1 squared is 1, minus 5 times 1 would be negative 4. Negative 4 plus 7 is 3. So that checks out. So my solution is 6, 13 and 1, 3. Since we do have y equals, this example would be okay to put in the graph. We just go to y equals on the calculator and type this in and type that in and do the second calc intersect, and you could find these two solutions. Or you could look in the table. Either way, this is a nice example you could just use a calculator for. This next one is a little bit piece of work. So I'm going to add x squared over. That leaves me y equals x squared. I'm going to get these in standard order. So I have my square term, then my linear term, then my constant term. So I have 4y minus 8x equals negative 21. If I solve for y, I'm going to have fractions running around. You could do that. I'm not going to. But I do have an equation solved for y, and I have a y in my linear equation. So I'm going to take this and put it in here for my y. Everywhere where I'm going to make a substitution, I need to put a set of parentheses. Because I have some negatives running around, I don't want to misplace a negative. So I have 4, and then I have parentheses. And I'm putting in x squared minus 5x plus 7 in those parentheses. I have 4 on the outside. So I'm going to bring it on the inside. I'm going to distribute. Everyone gets a 4. 4 times x squared is 4x squared. 4 times negative 5 is negative 20. 4 times positive 7 is 28. And then I have another term, negative 8x. And it's equal to negative 21. Now I'm going to combine my like terms, so I'm going to add 21 over. I have negative 8 and negative 20. So my x squared didn't have anything to combine with, so it's still 4x squared. Then I have negative 20x, negative 8, becomes negative 28x. Then I have 28 plus 21. So that's plus 49 equals 0. So I could factor. I'm going to end up with some big numbers, so I'm just going to do the quadratic formula. I'm feeling kind of lazy. So I'm going to go alpha y equals enter. Brings up my fraction. Quadratic formula, negative b, and I said my b was negative 28, so a negative of a negative is a positive. So I'm going to start by adding the square root first. So it's negative b plus or minus a square root of b squared. So a negative squared, that's a positive squared, minus 4ac. So 4 times 4 times 49. And it's all over 2 times a. Gives me 7 halves. So now I'm going to arrow up and find the negative of the square root. So it's a minus sign. So I only have one answer, 7 halves. So if I only get one x value, I'm only going to get one y value, so I only have 1 point. These two functions intersect. I'm going to use the equation I already have solved for y. So I'm going to square this, and then I'm just going to plug that in the calculator. 7 halves squared For this, I do need to put parentheses around 7 halves. I square it. Then subtract 5 times 7 halves. And again, I'll put parentheses around 7 halves. Plus 7. And I get negative 1.75. So that's how I put it in the calculator. And if I press math, the first option I get is frac. That's going to put my answer in a fraction if it can be put in a fraction. So if it's rational. 7/4. So my solution is 7 halves, 7/4. So the last example for systems of linear and quadratic equations. In the year 2000, Courtney and Kylie each received $2,000. Courtney decided to put her money in her closet, and each year added $200 to her money. That's kind of questionable. Kylie decided to invest her money in stock. That's also questionable. The value of her stock climbed according to a parabolic curve and peaked in 2004 at $3,920. That's pretty good. By 2006, the stocks had fallen to $3,320. That's not that bad of a drop. Formulate a system of equations to determine how many years it would take for the amount Courtney has in her stash to be equal to the value of Kylie's stock. So I need to make a chart. Courtney versus Kylie. Let's see who's smarter. So it gave me two things about Courtney. She started with $2,000 and every year she added $200. So I get, that's the linear. So I got my m and my b, because the linear equation, that's y equals mx plus b. So it gave me a slope, that's how much she added each time, each year. That's my slope, that's $200. And b is my starting amount, that was $2,000. So her equation is 200x plus 2,000. Kylie is going to take a little bit more work to figure out her equation. It says parabolic, and it gives us 3 points in time. It tells us at 2,000, which I'm going to use that as a 0. So when she started, she had $2,000. And then 4 years later, she had $3,920, which I would have pulled out of the stock market by then. Then 2006, that's 6 years after she started, she had $3,320. So I have 3 points. I know it's a parabola. It told me it was a parabolic curve. I need to go and put that in the calculator. I'm going to do the stat. Edit and all that. So I'm going to put my data in L1 and L2. So I went to second mode. Well, let me clear. You start by pressing stat and you want edit. So I have my data in there. So I'm going to go back home, second quit. I'm going to go back to stat, and I want to calculate the linear regression. I'm sorry, a quadratic regression. It's 5. Because we have a quadratic. So yes, I put my x's in L1, my y's in L2. So go down, calculate, and it tells me my a, b, and c. And it tells me that my equation is in the form of y equals ax squared plus bx plus c. So I take my a, my b, my c, and just place it where it tells me to. And all the question asked me to do was formulate. So I formulated. And I got my system to be y equals 2x, or 200x plus 2000, and y equals negative 130 x squared plus 1000x plus 2000. So all it says, formulate. I formulated. Those are my equations.